Welcome to another exciting mathematics video brought to you by Up Vision Concepts. Today, lesson will be on mensuration. Where we'll break down perimeter, area, volume in the simplest form. By way of introduction, mensuration is a branch of mathematics that deals with the measuring of lengths, areas, and volume of different shapes and objects. So the key terms that we have here is perimeter, we have the area, we have the volume. These are the key things that we're looking at for different kinds of shape. Now, when we talk about perimeter, we're talking about the length of all the sides of the shape. So we're considering the total length of all the sides of the shape. So we need to add, we'll add. If the shape is a regular shape, you just add all the sides. If it's irregular, you add the sides as well. So the area is the amount of space inside a shape. Amount of space inside a shape. Now, mind you, for perimeter and area, we're looking at 2D, two dimension. So, but volume of any shape, any quantity is the amount of shape or space, inside a 3D entity or space. So for perimeter, because we are just measuring the length of the O, the unit is meter or cm or millimeter, as the case may be. For area, the unit, by the time you do your calculation, the unit is in meter square or centimeter square or millimeter square or kilometer square, as the case may be. And for volume, the unit of measurement is in meter cube and cm cube, millimeter cube, as the case may be. So please dive into some of the basic formulas that we'll be interacting with in mensuration. The first one we'll see here is the perimeter of we'll look at the perimeter of a rectangle, because we defined it shape by shape. So perimeter, we'll look at it by shape. First of all, we'll see a rectangle. How does a rectangle look like? Let's visualize it. It has 4 sides. 2 of the sides are equal. This symbol means that this one is equal to this, and this means that this one is equal to this. So if this one is the length and this one is the breadth, this is also breadth and this is also length. You see that when we define it as the summation of all the sides, it is actually B plus L plus B plus L. So I start with this B and go anti-clockwise. B plus L plus B plus L. That's the perimeter. But we can do the algebra here. So I have 2L plus I have 2B. So perimeter, if I bring out the 2 outside, is 2 into L plus B. So that's the perimeter of a rectangle. I'm using the rectangle as a point, as a reference for everything. I can also get perimeter of a cylinder. Sorry, of a circle. Cylinder is a 3D. Okay, we can also get of a circle. Perimeter of a circle. This is a circle. The formula is 2 pi r. That's the whole length. The whole length. 2 pi r. That's the length of the uh, the length of the circle. We can only either call it perimeter of the circle or the circumference of the circle. For triangle, we're still talking about perimeter. Let me just erase this one. Okay. For triangle, because we define the perimeter as the sum of all the sides, it is actually sum of all the sides. So if I have a triangle like this, I want to visualize it. A, B, C. So it's just say A plus B plus C. All the sides. That's the perimeter of a triangle. Now let's go to area. Let's go to area. Area is the amount of space inside the shape. The amount of space that is particularly for 2D shape. So for area, first I would look for rectangle. I would say area is length times breadth, or LB. For circle, area is pi r square. Area is pi r square measured in meter square or cm square. Okay. What else again? Circle, triangle. Okay. Then I want to go into calculations. Area for 3D. Okay. I'm not done for that triangle. Area for triangle. Area of triangle is half the base times height. So I'll just take some preference to a triangle. I see that this is the base. The base is the point A to point B. You understand? So this is the base and this is the height. B to point C. That's the height. So if I have this and I have this is the formula to get the area of the triangle. The perpendicular height, so that's what I'm talking about. So that if the triangle is not a rectangle triangle, if the triangle is an equilateral triangle, for instance, like this, you understand? The base is the side that sits on the ground. This is the base, and the height is the perpendicular height from the apex to where it intersects to that base. So this is the height for this kind of triangle. So we're going to be seeing all those things in calculations. Now let's quickly go to 3D shapes. 3D shapes. So volume, 3D shapes. So for 3D entity, volume of a cuboid, for instance. What's a cuboid? A cuboid is something that looks like this. It's a six-sided shape. So these are hidden details. That's from this view. They are hidden details. So that's why I'm doing like that. So I'm sure you have seen a cuboid. A cuboid is formed from a triangle. So this one is one of the triangle. This is another triangle. The one at the back is a triangle. That's 1, 2, 3. One on top, the one beside, and the one under. So these are triangles. Then here and here. So 1, 2, back 3, down 4. This first side 5, and the last side 6. So there are 6 sides of a cuboid. 6 sides of a cuboid, and the surface area. So we talk about surface area for cuboid. Surface area is the area of all the 6 of them, the surfaces. So look at it this way. If I take this first side like this, the area, area is length times breadth for what's it called, for rectangle. So if I take this side like this, it's length times breadth plus. Now you know that this length times breadth, this side has a twin side. So I can say 2, that's 2 outside, length times breadth for this side. You understand? So I can still come again and take for this side and say length times breadth again plus 2 length times breadth, then plus, that's this side has a mirror, this one has a mirror, this one has a mirror, up has a mirror, 2 length times breadth. Now, depending on the keyboard size, it could be different lengths. You understand? It could be different lengths. Okay. Now, you can do it this way to differentiate the length. One of them, this is LB. This is LB. This one can be BH, big letter B and H. And the last one can be HL, H and L. Okay, so let me explain further. You know, this one now is length and breadth. So this is length, this is breadth. That's this one. And this one has two sides. That is this side and this side. Understand? Then when you come to this side again, there's a height. There's a height. So this same B that is forming rectangle with this one L is forming rectangle with this H. That's why I have it as a BH. Okay, the same B now, BH. You understand? And it's two of them. Now, if this is H here, this is H here. This H is forming another rectangle with this one at the back, and L is L here, the same L. That's why you have LH. You understand? So you can decide to say 2 is common in all these terms. So I can bring 2 outside. LB plus BH plus HL. So that is the area, surface area of a cuboid. So you can do the same thing for a cube. A cube is a cuboid, a cube that has a six-sided shape that has 6 equal parts. All the sides are equal. If you look at the old sugar cube that we used to have, that's a typical example of a real cube. Okay, so we have seen surface area of a cuboid and invariably a cube. Then volume of a cuboid. Volume. Let me just put it here so I can finish cuboid. Volume of a cuboid is now this is the cuboid. The volume is actually the total area, space covered by that 3D shape. So the volume of a cuboid is actually the length times the breadth times the height. That's the volume. It's a multiplication thing, and it's all measured in meter square or centimeter, sorry, cube. This is meter cube, centimeter cube, as the case may be. As the case may be. All right, so that is for the volume of a cube. So we'll go to cylinder. Cylinder, we'll discuss surface area and the volume. So cylinder, quickly. So for cylinder, so the surface area is equals to, for cylinder, surface area is equals to 2 pi arrow, open bracket, small arrow plus h. That's 2 pi radius, open bracket, radius plus h. This is the surface area of a cylinder. How did we come about this formula? We said area is actually surface area. Okay, so this is a cylinder. This is a cylinder. So let me put in the details. This is a cylinder. So there's a circle here, there's a circle here, the same circle. Let me put this line here is the radius from the center. R from the center. So it goes down like this to this center point again. So this is H. Okay, so this is a cylinder. Now, the cylinder has, if you can visualize, it has three parts. There's a circle on top of this place, another circle under. You understand? Another circle under. Then you now have this side that is formed if you open up the circle, the side that wraps, sorry, if you open up the side that wraps it round, if you open it up, it forms a rectangular shape. By the time you dissect this one, if you open this side that wraps around the cylinder, it forms a rectangular shape. This one forms a circle on top, another circle on top. So we are calculating the area of all these ones one by one. So this first one now, the area is pi r square, and it's 2 of it. 2 of it. Pi r square is 2 of it. Plus the area of this one. Let's take this one as a rectangle. Length times breadth. You understand? Length times breadth. This breadth now is the height, and the length upstairs is actually 2 pi r. You know, that length is actually the length of the circle. By the time this one wraps again like this, this rectangle wraps again around like this, it becomes a circle. This up becomes a circle. So the area of that circle, sorry, the perimeter of that circle is this. That perimeter forms the length or the breadth. You understand? From here to here, it forms it. So that's why we're using pi r square. Pi r square is the breadth times h. So this is actually dissected. The area, the surface area. So it's actually the surfaces that you are calculating the area for. We have gotten one component. The component we are gotten now is the area of the two circles, up and down, up and down. That is this one. Then the area of this length that wraps around the fringes of these two circles to form the cylinder is actually the length times the breadth. Okay, I will take this one now, h as the length. That's this one. The breadth is actually from here to here, and that breadth forms a circle. How to get that length, it is the circumference you are going to use. That's why we're having 2 pi r. So by the time you do the maths, you will just what's it called? Factorize. This one is common. 2 pi r is common. Then what is left here is r. What is left here is h. That's why I'm having it like this. Okay, so that's the surface area of a cylinder. Sometimes you need to draw it out so that you can visualize what we're saying. The next one is the volume of the cylinder. This one is just simple. It's just to get the volume. The volume is pi r square then h. The volume is pi r square. That this pi, that's the first one, not the two. The first circle, the area of the first circle times the height of the cylinder. That's the volume of the cylinder. Okay, so the next one is sphere. We're going to be looking at sphere. What is a sphere? A sphere is like football, like football. Football, the way football is a sphere. That's the shape. So a sphere. Okay, so we have the volume surface area of a sphere. Surface area is equals to A, that's surface area A is equals to 4 pi r cube. 4 pi r cube. 4 pi r cube. Okay, this one is actually the surface volume, but this is sphere. 4 pi r square. And the volume of a sphere is 4 pi r cube. That's the difference. And the surface area of a sphere is 4 pi r square, and the surface area of a cube the volume of a cube is 4 over 3 pi r cube. 4 over 3 pi r cube. There is an aspect of a sphere called a hemisphere. The hemisphere is half. Okay, if this is a sphere, like I said, football, it's not round, just round like that. It's a 3D circle, football. A hemisphere looks like this. You understand? This is a hemisphere. So it's actually the half of this. So for hemisphere, anytime you see hemisphere, if it is surface area, you are halving this one, you are halving the area of a surface area of a sphere, and if it is a volume, you are also doing this for hemisphere. So what are the real life applications? The real life applications for these shapes, you see shape. What are the real life applications? Is it just to calculate perimeter and calculate area, surface area? They just give you and you calculate. The real life application is in things like fencing. When a garden is fenced, you fence a garden. You understand? So you measure the border and the boundary length of the garden. So you can calculate the area or calculate the perimeter. If you want to do fencing now, you can now calculate the total length, the fence will run. So that is perimeter. Or when you are laying cables, you understand? In telecoms, you are laying cables or you are laying pipes. You understand? These are just the application for perimeter. For area, you can be painting a wall, so you can calculate the paint needed. Understand? If you are flooring and you are using tiles to floor, you can calculate the tiles needed. So volume, real life application could also include filling a swimming pool with water. So the volume, the amount of water that can fill a swimming pool for the various aspects, you can also do that. Then packaging designs, these are the applications. So let's quickly go to a question here. Let's solve the question here. Under cylinder, I'm going to give us a question under cylinder. Okay, this spelling is cylinder. Cylinder is C-Y-L. Cylinder, volume and surface area. Volume and surface area. So I'm going to take a question under this. So the question here is a cylinder or a cylindrical water tank. Water tank has a height of 14 meters. This is 14 meters, and a base radius of 3.5 meters. Okay. The external surface of the tank in brackets curved plus 2 cylindrical, 2 circular, curved and 2 circular. Let me erase this one. Curved and 2 circular ends is painted at 120 naira per square meter. So find the total surface area of the tank, and B, the cost of painting the tank. Okay, so you see how this can be applied in real life. So it says that we first of all find the total surface area of the tank. That's question B. Straight up, the formula for finding the total surface area of the tank as I gave us before, is, as I'm doing A now, is total surface area is what? Um, 2 pi r square plus 2 pi r h. Remember, you are seeing this one now is the circle, up the top circle and the down circle, the two of them. That's why it's having two, the area of the two of them. And this one now is the area of the body. That's curved body. So just put the parameters. You are given something there. Pi is always 22/7. Then arrow is given as what? Arrow is given as what? 3.5. That's what you have. Then height is what? Height is 14. So we just plug the values there. A is equals to 2.22/7 dot 3.5 all square plus these two again dot 22/7. Dot is multiplication. No, please, as you are saying dot in your mind, multiplication. Arrow here is 3.5. See how I bracketed it. Then dot h is 14. So we just do the maths. By the time we are done here, you can punch with your calculator. So it's 2 dots. This whole of this one will give us a value. Will give us 38.5 plus again 2 dots. The whole of this one will give us 154. So A, total surface area, is 77 plus 308, which is equals to 385. Remember, you are meter square. See, your unit is meter square. Don't in some exams, they will give you this one, this same as an option, and they put meter square. Give you another one, this same option, and I put meter cube. Just know that when you're looking for area, your answer is in meter square. If it is circumference or perimeter, it's in meters because you're measuring length. You're measuring length. Okay, so we have gotten the answer for the A part. Now the B part is the cost of the painting. The cost of the painting. So how much will it cost? If we have gotten the area, the total area, you understand? And they said that see the last question said that it's painted at 120 naira per square meter. So this is the total square meter. So each of this square meter here, each of the one inside here, I'm trying to break down the grammar or the English. Each of this here is costing this. So how much will everything cost? That one is easy. So I can take this one off. I can take it off and just do the maths. Just multiply. So I say question B is total cost, the cost of painting the tank. The cost of painting the tank. Painting the tank is what we got is 385, right? Meter square times 120. So by the time you do the maths, you get 46,280 naira. So that is the total cost of painting. The total cost of painting the tank. Okay, so we're going to go into another application where we're looking at cube. We're looking at cube and cuboid. Cube and cuboid quickly. So at this point, you might like to subscribe to the channel if you are new, and if you have questions, you can engage us in the comment section and like the video as well. So we have cube and cuboid. Let me just give us example, cube and cuboid. Now for this cube and cuboid, there's a question here. It says a rectangular box with a length of, I didn't reach of 24 cm. Please cm here, comma, this comma, then breadth 18 cm, and height 120 cm. Okay, is melted, okay, and recast into cubes of size 6 cm. Find A, the volume of the box, B, the number of cubes that can be formed, Okay, so this is another practical example. It says a rectangular box, a rectangular box with a length of 24 cm, breadth 18 cm, and height. So we are given that L is equal to what? 24 cm, comma, breadth is equal to 18 cm, and height is equal to 12 cm. Okay, so now we can get the volume of the box. That one is not difficult. It's not difficult. What's the volume? Volume is given as LBH, length times breadth times height. So just plug in what you have here, 24 times 18 times 12. So what will it give us? The length. By the time you compute, 5184. 5184. 5184. 5184 what? Cm what? Cm cube. Please remember this units. Remember this unit. Very, very good in your units when you are solving maths questions and maybe physics questions as well. Now, the B part is very interesting. This is the volume of the cuboid, the rectangular box. You understand? Rectangular box, the cuboid. So the space is occupying is this. You understand? But when you melt it, this is also the space that the melted mass will have. Now, this melted mass will now be used to reconstitute, you understand? Reconstitute small cubes. Small cubes. Nothing will be lost. Understand? They reconstitute small cubes, and each of the cubes have 6 sides. So these cubes that have 6 sides, what is the volume of the cube? You understand? The volume of the cube. So B part says the number of cubes that can be formed. First of all, volume of the cube formed. Volume of cubes formed is equals to L cube. What's L? L is 6. So 6 cube is what? 6 cube is 216. 216 cm cube. Now, how many cubes will be formed from this? So just divide this by this. So number of cubes formed. Number of cubes formed from where? From that cuboid that was melted is equals to 5184 all over 216. So the number is 24 cubes. 24 cubes. Note the units. Note the unit. You didn't change from cm square to 24 cubes. So that's the answer. So we'll solve one final example under sphere and hemisphere. Under sphere and hemisphere. Okay. Okay, so I have sphere and hemisphere volume. Sphere and hemisphere volume. Okay, so example under this topic, it says a solid metal sphere of diameter is what? 14 cm is melted. Again, we are melting. Is melted and recast into small hemisphere of radius 3.5 cm. Find A, the volume of the original sphere. B, the number of hemispheres formed. So we are to take pi as 22/7. Take pi as 22/7. So this one is also clear. It's a solid metal sphere of diameter 4. Diameter tells you that, sorry, 14. Diameter tells you that the radius now become divided by 2. The diameter is actually 2 times the radius. So if you're given diameter in the question, just divide it by 2 to get the radius. Okay. So it's melted and recast into small hemisphere of radius. So there are two shapes now. The sphere, that football shape, let me put it here, that football shape is now recasted to form hemisphere. That's half of it. And they cut it into 2. So they recast it. So they said, how many hemispheres are formed? Obviously, you don't go and say 2. Don't go and say 2 because it's half. There might be hemispheres that are actually smaller than this radius here. Of course, the radius is even small already, so you don't just say 2. Let's take it step by step. Number 1, find the volume of the original sphere. Now, we were told I gave you that the volume A, the volume of a sphere is what? Volume of sphere is 4/3 pi radius cube. That's the volume of a sphere. So all the parameters are there. Where what? For the big sphere, where R is what? 7. Why? Because 14 divided by 2 is 7. You understand? So just plug in what you have. 4/3 times 22/7 times 7 cubed. So the volume of a sphere, by the time you compute with your calculator, is 1437.33. 1437.33 cm cubed. Mind your units. Okay. Now, for the hemisphere, I said hemisphere is half. The formula is half of this. So for B, we have gotten A. Now, number of hemisphere. To get number of hemisphere, first of all, find the volume of this hemisphere. So volume of hemisphere. Volume of hemisphere is half of the formula of the volume of the sphere. By the time you put your values, 1/2 times 4/3 times 22/7 times this arrow now at this time is now the hemisphere, 3.5 cube. By the time you complete all this, the answer, I hope you are seeing the board, the answer is 89.83 cm cube. 89.83 cm cube. Okay, now note, let me take this one up a little bit. The answer for this is 89.83 cm cube. So I have two things here. I have the volume of the sphere and I have the volume of the hemisphere. So how many hemispheres are formed? Just divide this by this. So let me take this one off and divide. Okay, I've taken that one. Don't worry. Just, you can pause the video and check. But the number of hemispheres, B, number of hemisphere formed is the volume of the original sphere, which is what? Which is 41437.33 all over the volume of the hemisphere we just derived is 89.83. By the time you divide it, approximately you get 16. So there are 16 hemispheres formed. 16 hemispheres formed if the original sphere is recasted and made into hemisphere of this radius. So this is where we will stop for this particular topic. We'll have another video that will continue mensuration. Mensuration is actually a very broad topic. We have different complexities, even shapes like frustum, the buckets, and so on and so forth. So we'll upload another video where we'll continue with mensuration. But so far, I hope this has been informative for you. I want to encourage you to subscribe. If you're new to the channel, please subscribe so that you can be getting videos as we upload them. And also invite people to subscribe and join this train. I want to thank you for viewing.